In the name of Almighty God, I'm Mahsa Sankoshi, and today I want to talk about Aperture shape optimization for electroplating of a printed circuit board. Electroplating is the process of using electrodeposition to coat an object in a layer of metals. Engineers use controlled electrolysis to transfer the desired metal coating from an anode, a part containing the metal that will be used as a plating, to a cathode, the part to be plated. Aperture shape optimization is a method used in both radiation therapy and electroplating to determine the ideal shape of an aperture for a specific purpose, such as delivering a radiation dose to a tumor or plating a metal layer. In radiation therapy, it's a key part of direct aperture optimization for intensity modulated radiation therapy and involves directly optimizing the shape and weight of the radiation fields to precisely target a tumor while sparing healthy tissue. In electroplating, it optimizes an aperture size and aspect ratio to achieve a uniform deposit metal layer on a workpiece, like a printed circuit board. In radiation therapy, the first is goal to create precise radiation fields for cancer treatment by optimizing the shapes and weights of apertures controlled by a multi-leaf collimator. The next one is direct aperture optimization, an inverse planning technique that directly determines the aperture shapes and their intensities at each angle. The next one is methodology. Algorithms use gradient information to locally optimize the positions of the collimator leaves to minimize the dose to healthy tissue. The next is benefits leads to high quality treatment plans with fewer radiation fields for more efficient delivery. The next one is challenge. Challenge can be difficult to make robust for all target sizes and shapes and may not always rival the quality of beamlet-based optimization. And in electroplating, the goal in electroplating is to ensure a uniform deposition of metal by optimizing the shape and size of an aperture. The next is methodology. Software like COMSOL can simulate the process and use shape optimization to find the ideal aperture to minimize variations in thickness across the plate surface. The next one is application, often used to improve the plating process for components like printed circuit boards. And what are the key optimization principles? The first one is gradient based methods. Many techniques rely on calculating the gradient of an object function to iteratively adjust the aperture shape towards an optimal solution. The next is what are the constraints? The optimization process must consider physical constraints such as the speed and travel limits of multi-leaf collimator in radiation therapy. The next is objective function. The goal is to minimize or maximize a specific function. In radiation therapy, this might be maximizing the dose to the tumor while minimizing the dose to healthy tissue. In electroplating, it is maximizing the uniformity of the deposit. Electroplating, also known as electrochemical deposition or electrodeposition, is a process for producing a metal coating on a solid substrate through the reduction of cation of the metal by means of direct electric current. The part to be coated acts as the cathode or negative electrode of an electrolyte cell. The electrolyte is a solution of a salt whose cation is the metal to be coated, and the anode or the positive electrode is usually either a block of the metal or of some inert conductive material. The current is provided by an external power supply. Electroplating is widely used in industry and decorative arts to improve the surface qualities of objects, such as resistance to abrasion and corrosion, lubricity, reflectivity, electrical conductivity, or appearance. It is used to build up thickness on undersized or worn out parts and to manufacture metal plates with complex shape. A process called electroforming. It is used to deposit copper and other conductors in forming printed circuit boards and copper interconnects in the integrated circuits. It is also used to purify metals such as copper. The aforementioned electroplating of metals uses an reduction process, that is, a negative or cathode current is on the working electrode. The term electroplating is also used occasionally for processes that happen under electro-oxidation, for example, positive or anodic current on the working electrode. Although such processes are more commonly referred to as anodized rather than electroplating. One such example is the formation of silver chloride on silver wire in chloride solutions to make silver or silver chloride electrodes. Electropolishing, a process that uses an electric current to selectively remove the outermost layer from the surface of a metal object, is the reverse of the process of electroplating. And Turing power is an important parameter that provides a measure of the uniformity of electroplating current and consequently the uniformity of the electroplated metal thickness on regions of the part that are near to the anode compared to regions that are far from it. It depends mostly on the composition and temperature of the electroplating solution as well as on the operating current density. A higher Turing power of plating bath results in a more uniform coating. Thank you so much for watching my tutorial video until the end, and you can see that I have used two different physical modules as shape optimization and secondary current distribution. And as you can see here, there are boundary condition and equation, and you can see the result as the different result: electrolyte potential, electrolyte current density, and the electropotential with respect to ground, and the different thickness on the cathode and the aperture shapes. Thank you so much for watching my video until the end, and also you can download this simulation from my github.com/masterscript.